Thank you very much for joining us today here in this seminar. Dear delegates, dear colleagues at the OECD, dear guests who are also joining us online, I'm delighted to open now the PI seminar, which is organized by the Productivity, Innovation and Entrepreneurship Division here in the Science, Technology, Innovation Directorate. My name is Samek. I'm an economist here in this division, where I actually work a lot on AI diffusion, but I'm also co-leading the work on semiconductors, and I'll be chairing the seminar here today. Now, today it's our honor here to welcome Professor Francesco Venturini, who is sitting next to me here. He's an associate professor in economics at the University of Urbino. He's a research associate at the Economic Statistics Center of Excellence, which some of you may know as ESCoE, a research affiliate at Circle, and also a fellow at NIESR, or the National Institute of Economic and Social Research in London. Now, Francesco's research studies the impact of innovation and technological change on economic growth and income distribution. His current work focuses a lot on AI, and we will actually hear much more about this in today's presentation, but also on medical innovation and on novel data methodologies. Now, today, Francesco will be discussing his paper that's in its early stages, analyzing the development of AI in Italy in particular between 2014 and 2023, using firm-level trademark, patent, and balance sheet data. Now, before I will begin, I would like to remind everyone of just a few housekeeping rules here in the room, but also everyone joining us online. This event here will be conducted in a hybrid format. For those in the room here, if you wish to ask any question, please just raise your hand and please use the microphone. For the virtual participants, you're welcome to ask any questions through the Q&A feature that we have here on Zoom in the application, or just post it in the chat. Should you wish to speak, then please raise your hand, and our technical team here in the back will help me in enabling the microphone and to give you the floor. Now, before I'm handing over to Francesco to start his presentation here, I'm pleased to invite Kezban Akkurt, who is head of the department at the Ministry of Industry and Technology of Turkey and the CIE vice chair. Kezban, the floor is yours.
Thank you, Leah, and nice to see you online. Good afternoon, distinguished colleagues. It's a great pleasure to welcome you to today's seminar looking at AI through the lens of the IP data. We have gathered policymakers, academics, and intellectual property experts around the shared questions that is both timely and fundamental. That's how can we better understand the real economic impact of artificial intelligence by looking at how firms protect, brand, and commercialize it. AI is transforming the way we work, communicate, and innovate. On the other hand, when we look at the aggregate productivity statistics, the effects still appear modest and uneven. This is not entirely surprising. The literature increasingly frames AI as a GPT, a technology that is not confined to a single sector, but instead reshapes entire economies. History teaches us that such technologies rarely deliver their full productivity gains overnight. As research on past technological revolutions shows, their real impact emerges only when they are diffused widely across firms and the sectors, supported by complementary investment in skills, organizational change, and new business models. And recent work reflects this dual reality. At the micro level, the productivity effects of the AI still appear limited. Yet AI at the macro level, form and workload-based studies are starting to show substantial gains, from more productive customer service agents to software developers to firms achieving higher sales and the efficiency when they adopt AI tools. So the real question becomes, how do we track these diffusions? How do we see where AI is actually entering the economy, not just in research labs, but in products, services, and the markets? This is where today's seminar makes an important contribution. Traditionally, we have relied heavily on patent data to measure technological innovation, and patents have taught us a great deal. They show that AI invention is highly concentrated in small number of large, technologically advanced firms and the sectors. They reveal where the technical frontier is moving, but patents also have clear limits. They do not cover all branches of the economy. They tend to miss service sectors, They often underestimate innovation that is protected through the embedded in business models rather than technological inventions. And perhaps most importantly, patents tells us much more than invention than commercialization. In other words, patents tells us where AI is being created, but not always where AI is being used. This is why the approach presented today, looking at trademarks as a complementary lens, is so powerful. So trademarks capture something different. They capture the moments when innovation reaches the market, when a firm launches a new product, a new service, or a new brand identity. They reflect not just technological novelty, but economic intent, including differentiation, positioning, and also value creation. From the analytic perspective, trademarks also allows us to observe innovation in all sectors, including services, the diffusion of new technologies beyond the core high-tech industries, and the commercialization of what we might call soft innovation, the ways of combining technology with business models, design, and the customer experience. So today's research builds on this idea in a very concrete way. Using firm-level data from Italy over nearly a decade, the authors combine AI-related patents and AI-related trademarks to examine two questions. These are also very exciting for us. First, what drives firms to develop and protect AI-based innovation using different IP strategies? And second, what happens to firm performance after they introduce AI-related trademarks? So this brings us perhaps the most policy-relevant results. In other words, trademarks are not just legal instruments. In this context, they become economic markers of the successful AI diffusion. So the sectoral dimension is also important. The strongest productivity effects appear in knowledge-intensive and the service-oriented sectors, including areas that are often underrepresented in the patent-based analysis. So this reinforces the idea that AI's transformative potential is confined to traditional high-tech manufacturing, but it is deeply tied to how services, data, and the digital capabilities are integrated into everyday business activities. So looking ahead, maybe the planned extension of this work to other European countries and the regional level mapping opens exciting possibilities. It can help us identify AI innovation clusters, diffusion gaps, and emerging specialization across regions. So this is providing us a strong evidence base for targeted place-based innovation policies. So let me close a broader reflection. AI is often described as a technology of the future. But what today's work shows us that its economic impact is already taking shape, not only in code and algorithms, but in brands, services, and everyday practices of firms across the economy. So by looking at AI through the lens of the IP data, and especially through the combined use of the patents and the trademarks, we move closer to understanding not just where AI is invented, but it truly becomes economically meaningful. With that, it is my pleasure to welcome presenter and discussant. I believe that these discussions we will have today will help lay the groundwork for our future work in the period ahead. Last but not least, I would like to thank OECD Secretariat and all the presenters for the insightful seminar. Thank you so much.
Thank you very much, Kezban. Now it's my pleasure to open the floor to Francesco and invite you. So we are excited to hear from you. Thank you.
Okay. Let's try. Okay. Thank you very much, Leah. Thanks for this invitation. I'm very pleased to present today this ongoing work. We are going to present the data on a work in progress work with Carolina Castaldi, Fulvio Castellacci, Andrea Fronzetti Colladon based in Rome, Ludovica Segneri, she's here from the University of Urbino. And The idea of the paper here is to indeed to investigate the the firm engagement in AI, going beyond patent statistics, or which has been my field of research so far. And what we we have seen an explosion of AI literature. So AI for sure, general purpose technologies, because we see a mass of works trying to explain what AI is, what AI produce at firm level and aggregate level. So maybe we can all agree about the fact that AI is not producing so big productivity outcomes at the economic level. According to the most optimistic prevision, so AI could increase the rate of peak growth by less than 1 percentage point in the next 2 decades. On the other side, we see a lot of evidence, an increasing amount of evidence showing that AI is producing some positive effects at firm or worker level. And Flavio has some different work on French data showing that AI using and developing companies has higher productivity than the company without AI with similar characteristics. AI adopters in Germany have been found to have an expansion of 30% of sales after the introduction of AI. And this is what we know. This is just some insight from the literature that we have at firm level. There are some other work that focus on the effect of worker level of generative AI. So, and for some group of workers, the pattern productivity of generative AI could be much higher. So, AI-assisted customer agents have been found to have a higher 50% higher productivity compared to the counterpart. And software developer, of course, people coding software have a much higher productivity improvement. Okay, so in the research that done so far, I mainly use patent data, and more or less the evidence that I found in different works seem to line up to what we have in the literature. So at the economic level, the impact of AI, when measured in terms of AI development, so with patents, so the effect is not so wide. Let's say may arrive 3% in a productivity level increase in decades, because this technology is likely to produce effect with some delayed J productivity effect and so on. In another work, basically we construct a regional level data set and using patent, so we map patent data regional level, so including Japan, US, and so on, and we measure the effect of AI on the GDP per capita growth of the region. So we find a very little, very small effect, and so AI doesn't seem to widen so much income growth disparities across regions around the world so far. Again, similarly, using regional level data in Europe, we see that, and looking at the factor distribution, so we define that AI region we specialize in AI production, so seem to experience a fall in the labor share on income, but this fall is significant, but it's very small. So 0.5 percentage point decline in the regional labor share can be somehow ascribed to AI and how the impact of AI of factor income distribution. However, when we move to firm level data, so the impact of AI seems to be much wider and significant, quite robust. For instance, looking at company level data for Europe, in a relative old paper, we do find that company innovating AI are generally large company with a strong expertise in the ICT domain, so previously patented in digital fields. And also, but the most important issue is that this company tend to exploit a strong little advantage. So once the first comer is to become more productive over time in getting more patents afterwards. So they technological advantage tend to be very cumulative over time. So they exploit the dynamic returns. In a more recent paper with some colleague at the University of Urbino, we also at least in the case of Italy, not for Europe, we are trying to understand whether the decision of company to move to AI is somehow related to the risk profile of the company. So we look at different risk profile of the company, and we do find that company with the higher financial risk, so which are company that are able to handle high volatility in liquidity condition, tend to move to AI much more than company that, for instance, decided to apply for industrial revolution patents. And for instance, financial risk is not doesn't play any role when the company decide to apply for an SCT patent. So basically, if we imagine the technologies like in a range of uncertainty, so we do find that the financial risk is more related to the more uncertain company. So company decide to move to the AI, which is the more certain, with the benefit are not very clear. So I mean, it is a very important characteristic that at least in Italy seem to play a role. And overall, when we look at the effect, so not the determinants, when we look at the effect of AI, at least in Europe, we do find a significant productivity premium for companies developing AI since the introduction of the first patents in the field. So, however, we know that patents are not good for covering innovation in the field for many reasons, because AI do cover just manufacturing. Patents are strongly concentrated in large firms. There are some disclosure issue because companies do not prefer to disclose the prior art, or prefer to disclose, a side prior art, in sense they use patent in strategic terms. So for this respect, we start looking at trademark. Trademark I go on fast on this background literature. So, trademark have been found to be used for innovation aims to appropriate the realms of innovation, especially when these innovations are developed in software or are non-technological innovation. And from this side, and also the most important is trademark are used by the company to signal that a new product is marketable, so in order to be recognized by potential customer. On this, and so far there is some study in the literature that have tried to relate trademark to the big industrial revolution, great industrial revolution, and the uptake of the great invention. And we see that at least with the uptake of the IT revolutions in the mid-90s, there's been like an overlapping increase in trademark when, for instance, patents have been used since centuries, let's say. In this area, the key references, the key starting point in the literature are the paper by Maria Grazia and Casato, 2021, where they map at the global level all AI trademark, and basically they do show that the trademark are highly diffused, and then companies used to employ AI trademark in order to protect a very large broad of computer and product and services. In a paper by Flavio and Lian and co-authors, they try to basically map AI adopters, crossing information of AIP at company level in the United Kingdom, so using information on patents, trademark, and merging this with information on AI hiring and on company website. And what they do find? They do find that AI adopters are highly concentrated in ICT professional service industries, and also are geographically clustered around London and other areas, very small number of areas. AI adopters are large, medium, and large size company, and their productivity in this group, AI adopters are much more productive than the control group in the same size category without AI. More or less 20% higher productivity for where productivity is a sales per worker, and for medium-sized company, and 35% for large-sized company. So I make this review because our work strictly relates can be seen like a development, a follow-up of your stuff. So basically, we use data for Italy from 2014, 2023. And we basically map all AI. We try to map all AI trademark in Italy, and also we want to understand which factor drive company to apply for a trademark, and and basically how firm performance in productivity terms change afterwards. And basically our analysis is not focused on a trademark, but basically we try to relate the company decision to apply for a trademark in relation to the decision or the previous decision to apply for other trademarks, so traditional trademark, and also patents. So we look at both trademark, patents, and we distinguish both in terms of AI and non-AI. So we try to focus on this, on this, and control of course for many different characteristics. So the analysis is done crossing Orbis management, trademark from IPO, and Google patents, because we do. Basically, the analysis is performed on 2 steps. In the first one, we try to identify the drivers of AI trademark applications, and also in the same, we also run some account data regression in order to see if there are some factors which may explain the different productivity, so different counting in AI trademark. And in the second part, we run, which is still preliminary, an event analysis to show whether company that introduce a trademark since experience or not an improvement TFP. So this is the outline of the paper. The results, briefly, we do find that AI trademarks are much more diffuse than AI patents in Italy. They are not geographically concentrated like patents, at least in our sample, which is small because figure very small, but comparable to Leah paper on the UK. Company decision to introduce a trademark seem to be related to previous patenting and to previous traditional trademarking, right? And again, we do find some dynamic effect. So company that have maybe, so we have a small number, but company that have applied for one trademark then have a little advantage compared to the other. So there is some cumulative effect. We do not find, we do find very small, let's say, not spillover effect, but proximity effect. So we do find that company which decide to apply for a trademark tend to concentrate in areas where, there are other trademark endowed companies. In this process, there is no, let's say, sectoral differences, basically, and there is no geographical differences in terms from south, north, or looking at distribution trademark across different provinces. What else? Company applying for a trademark are larger, more efficient, and more labor intensive. And so this is the main result of the first part. In the second part, in the event analysis, we do see that there is a TF increase in after the introduction of the trademark. So even controlling from feedback effect. So we'll show you later a bit more detail. And here we do find significant sectoral differences in the sense there are a bulk of a knowledge-intensive service where the TFB increase is stronger than in the rest of the economy. And so we will show you later a bit more of this heterogeneity that we find the results. Okay, so the first key point of the work is to identify a trademark. So basically, yes. Yeah.
Can I ask a maybe very silly question, but I think it's important for this. Are you going to explain the difference between a trademark and a patent in Italy and what rights they give, and are they substitutable? Can a firm choose to file one rather than the other?
On the same line, so you have also what you have in mind with an AI trademark, what it's representing for you, and the difference with patent.
Yes. Okay, so maybe I come back on this after I detail the methodology that we use clearly, because we do. Okay, so rapidly. So, oh no, sorry. Okay. Yes. So sorry, this one. Okay, so basically we use patents from Google Patents, Orbis, and trademark. So the key point to identify, I said, a trademark, and basically we follow the procedure previously used in Nakazato and Switcherini. So we create a dictionary of keywords starting of the dictionary on a trademark. We update that using the more recent literature. And basically we identify different dictionaries and we select the common wording. and so that we use our narrow definition of a trademark. So there are some. So basically, exactly, we start from that dictionary, but then we update. So this is the narrow definition, the strict definition. Then we update this dictionary. So using online news and also using additional terms taken from ChatGPT and other platform. In our analysis, basically, we do make I don't know if probably if you have done a close comparison between the definition of a trademark, and the different sample that we get if we use OECD dictionary or dictionary. In economic terms, the results are pretty similar, but the definition of a trademark is exactly the one developed here. So I don't know if I have to. Do we apply the same kind of dictionary on the text of patents? Okay. So I can get on more detail, but
I think my question was even simpler. It wasn't how you identify them. It's just if I'm a firm, first off, I think can you just give an example of an AI patent, something that a firm has patented that's AI, that's not a trademark? And what is an AI trademark that's not an AI patent? And then what margin do firms have to pick one versus the other? Because I think that's what the paper is about. So I'm just trying to understand.
Okay, yeah, patents, not yes. Okay, so I try to, so in order to cover an innovation with the patents, your innovation has to be endowed with some requisite, novelty, originality, so, and it has to show some jump compared to this previous state of the art technology. And I mean, some innovation, especially when they're intangible, difficult, maybe like an argument, it's difficult to show that they are a substantial difference from the existing state of the art. So this could be one reason for why a company may be able to apply for a patent or going for a trademark. So because some innovation may not have the requisite to be patented first. Secondly, company do use trademark in order to protect some maybe new products, AI-based, AI-related, which is ready to be marketed. So, which not necessarily could be substantially different from a product that has already onto the market, but is shaped in a way that is unique for the customer. So, I mean, the main explanation is about the technological contents of the innovation. One is more maybe, for instance, patents have been arguably used in manufacturing because I mean, for a product is much tangible. Innovation is much easier to show the degree or novelty compared to the existing state of the art. For trademark, you may also apply for a trademark to I mean, not only the AI field, but also to cover an organizational change or something which is related to marketing, advertising, so which is maybe more service related and maybe closer to the market, which is technique immediately commercialized. And the company, I don't know if I'm replying to your question. And
sorry if I may, just a follow-up question to really understand what we're talking about. Are you looking at patents filed in patent offices worldwide by Italian companies? And I'm asking this question because the patentability of some AI applications, in particular software, may vary across patent offices.
Okay, just to make AI trademark data comparable to patent data, we refer to Apple patent application because we use trademark for IPO. So this is the main reason why we focus on application at the patent office. I mean, yes, because I maybe.
I may. I think in Europe, what you can patent is computer implemented inventions. So it's not pure software patents, but it's software that are applied to specific inventions.
US, you can apply, you can cover by patents also software purely. Other question? Okay, so 1 second. Yeah, I think, okay, basically in Orbis, we have in Orbis 1.5 million company record. And after our data cleaning, we arrive at, we find our final sample is made by 400K company, and we match this with the trademark data. So basically, at the end of the whole cleansing and fuzzy matching, we arrive with a match sample of 14K company with trademark, which correspond to around 25K trademark overall. When we so our the main limitation in the data construction is because we want to build TFP, so we need the data materials and so on. We follow your stuff in building or economic variables. So our sample is made by overall a company with and without trademark general 400K, 14K have trademark, less than 5,000 have some patents, right? And when we do focus on firms with trademark, we do have only 263 company with AI trademark, of which and 29 have AI patents. So these figures are small, but are not very far from the data for UK, where you had 355 companies merging even online ads and so on. So the success rate or matching procedure process is not very far from what you have. This is what we get using our dictionary, which is a bit stricter than yours. But then we show what. So basically, we show the overlap and in the regression what we get using both. So 263 company with the AI trademark, 171 have one traditional trademark, at least one traditional trademark, and at least one AI trademark. Only 5 companies in Italy, according to our dictionaries, have one AI trademark or one AI patents. So very, very small figure. So basically, from this descriptive statistic, we saw that, these are 2 groups of companies, over less. And then as we show this econometrically. So rapidly, because our sample is made mostly by small firms, where the proportion of firms with trademark is much higher between medium and large set companies. Basically, if we focus on firms with a trademark, those having AI trademark correspond to 1% in small and medium sized and 2% in large size. When we focus on AI patents, the proportion of company is much smaller. So in terms of productivity, so we distinguish our sample of company with trademark, so into those having AI trademark and the traditional trademark. Those having AI trademark have, of course, clearly a larger number of a trademark. Secondly, they have a larger number of traditional trademark, but also are more productive in terms of patenting. So both AI and non-AI patents. So there is clearly a selection issue, selective issues that we try to address in our econometric analysis. Okay, so this is, this, I will show this. I will skip this. Okay, this is the. Yes, Luca, I can.
No, very small question. So the zeros in this descriptive statistics are what? So they're saying AI versus the rest, right? AI patents versus the rest. It's a firm which has other type of patents necessarily, or whether it has other patents or no patents at all, it doesn't matter.
The 2 groups. Yes, the 2 groups are company with have at least one AI trademark and the second company without. So, of course, the second group cannot have AI trademark, right? Yeah. Yes. Yeah. No, they do have. They do have. Yeah, they are selected on the basis of only trademark companies. So, select for these statistics, yes. Okay, so this is the geographical distribution of the total counts of AI trademark and total patents in Italy across NIESR level regions. And I mean, there is some clear overlap, despite it seems to be that AI trademark, AI patents seem to be more concentrated in Lombardy and Piedmont because of the manufacturing, clearly, while AI trademarks seem to be, more diffuse in Veneto, Emilia-Romagna, and Tuscany. So I do not have the pointer, but basically then in the northern part. Okay, so when we do, so this basically the previous figures show the differences in the AI patents trademark, big differences in the distribution, geographical distribution. When we focus on trademark, we do see that there are the previous outline derived from the fact that regions specialize in different sectors. So here we do show that there are some regions which specialize more on the use in some sector which are more intensive of trademark. And so this graph show the proportion of companies in our sample applying for a trademark or traditional trademark, and more or less overlap to the previous one, the previous figure. But again, for instance, Tuscany come out to be somehow more specialized in this. We have a greater number of companies specialized in applying for AI trademark. So sectoral differences. This is the distribution of the proportion of company with AI trademark and AI patents across sectors, not just sectors, 2-digit, and of course. The proportion of company with the AI trademark and patents are relatively high in the manufacturing. So on the left-hand side of the industry distribution. But as you see, for instance, in computer programming and professional services have a much higher proportion of company with AI trademark, which more or less resemble to what Flavio and Leah have found in their analysis on the United Kingdom. This reports the total counts of AI trademark and AI patents. And again, this in our sample we have a much larger. The most productive companies, at least if measured in terms of AI trademark, are concentrating in the two sectors that ICT and professional service. So more or less, our sample doesn't seem very different from what have been so far found in the literature. Okay, so what we do? Okay, in the first part, we run a regression, a pool regression, where we relate the AI, success of the company. So whether the company apply for an AI trademark or the number of AI trademark obtained against a set of coverages. That first of all, we look at the company in the past have applied or not some patents or some trademark, distinguish them between AI and non-AI. So that we call it as a first IP experience of the company. And then we construct also proximity measures. So the number of companies in the same area or sector having, because of proximity effect, competition effect, imitation effect, in order to see if there is some proximity. So we measure this, construct this spillover variable at different level. So in the first, this run as a pool probability regression or pseudo Poisson maximum likelihood estimator. We run this regression on both this full sample, so including company with trademark and company without trademark, so which is our large sample, but then we restrict the analysis for selection for selectivity issues to only two companies have at least one trademark. So in the second part, so of course we include a lot of controls, so employment for size, labor productivity, the labor capital intensity of the company, the capital share on company, the capital compensation on total company value added, and the measure of liquidity. So in the second part, instead we do look at the so we run a regression analysis where we relate the log TFP construct with the control function method based on the Woolridge 2009 against, a post-treatment and absorbing treatment. So to a treatment, we take the value 1 since the first year when the trademark has been introduced, controlling for all the other coverages that we introduced before. And we run this analysis with the local projection different diff where we compare the treated, so company that at a given point in our entire horizon have introduced an AI trademark, compare the control group of company with similar characteristics that we identify with a matching procedure. Okay, so basically, these are the main variables used in their analysis. So sorry, and basically we measure past IP activity of the company in terms of the total counts over time of AI trademarks, non-AI trademarks, so traditional trademark, AI patents, and non-AI patents. So we distinguish the route that followed by each company in the past. So results. Oops. Okay, these results are a result of probability regression where we try to predict the probability of the company to introduce an AI trademark against some proxy of his past experience in IP, and some proxy of proximity effect of AI trademark, controlling for the characteristics that we've seen. So basically, what we find is that company basically that some companies that have a past experience in applying for a trademark are more likely to introduce a new trademark. And if we compare this company with a bulk of company without trademark, clearly, there is also a differential effect for company having applied in the past for non-AI trademark. What we, however, the results are robust to different definition of a trademark. So in the first four columns, we use a strict definition of a trademark. We're using based on our dictionary. In the last column, we use OECD dictionary. And more or less, our results are pretty. We do a set of robustness check. Our results are pretty robust to different identification criteria. What we do see is that there is some proximity effect only when we confine to company, we measure this proximity effect at province level, so at NAS 2, 3 level, because when we construct a spillover variable at NAS 2, not NAS 3, so the spillover effect is smaller. So there is some highly localized proximity effect. When we construct our spillover variable at natural level, we do not have any evidence of proximity effect, technological proximity effect. Yeah.
So it's about trying to understand the empirical specification. 1 second. So so this is a panel still, right? I'm sorry, I missed the first. No, it's a. Pooled profit. Okay. Yeah. Okay. No, but yeah, exactly. My question was, for instance, why don't you try to control for this bunch of time varying sort of correlates, which I understand, but so why is there no within transformation here? So why no firm fixed effect essentially, right? So you can in principle.
The consistency of estimate is not sure with the
with the probability itself.
Yes,
but
we can move
to linear probability model, and then you and then you could control for that, which is more stringent. The other question is once again about the zeros, right? So and which means the let's say the sample you're matching your AI firms with. Is this a never AI, or is this a not yet AI?
No, never.
Never AI. So
never, not yet, but the result we are going to show is not never treated and balanced. Okay, so the most point is about selectivity. So basically, most of the variation is due to the fact that this company we saw that our company with trademark are totally different from company without trademark. So we focus on analysis on company with trademark, and the results change a bit. Not much, but change a bit. So we run, try to address selectivity with the NECA model, but maybe since it's late, I will focus on this. So where basically here we perform a regression analysis where we run column 2 and 3, 2 probability regression. So we try to model the joint occurrence of AI trademark against non-traditional trademark. So in order to see whether, there are structural differences in company which decide to apply for one AI trademark compared to the other, and try to control for non-servable, because, there are some factors that may be common between the two decisional processes, but we are not able to control. And this is what we have in column 2 and 3. So we basically, what we see that if we restrict to company with trademark, those that apply for AI trademark tend to be exploit dynamic returns. So their success tend to be explain what they've done so far in this area, but not if they have applied for traditional trademark. So it seems to be the AI company with a trademark is slightly different from company with trademark, but not acting in the AI domains. So this is even confirmed, but the error correlation that this is negative. So this tells us that there is maybe something that drives in different direction the company decision to apply for. In the last set of regression, we focus on basically on the decision of apply for AI patents or AI trademark. And so here, here we want to see whether there are again different the role our covariance is different or not. And what we see that the result on AI trademarking is pretty robust in the sense that a bit different. We here, of course, we do once we control for any characteristic. There is no company that decide to apply for AI patents that in the past applied for AI trademark. So we can identify the cross effect. But there is highly confirmed that company that apply for AI trademark seems to be highly affected by the previous activity in this area, and they are totally the decision totally related to traditional trademarking. What you see that the driver somehow for when we focus on AI patenting. So we do see that the decision of a company to apply for an AI patent somehow affected by the company itself past patent activity. So there is some follow-up or some cross effect from, for instance, ICT, previous engagement of the company ICT towards AI patents. This cross effect between technological domain are not found for AI trademark. So I'm going, okay. But we do not have differences. I skip all. We do not have differences between in the propensity to apply for a trademark. We do not have any difference between sectors, different sector groupings, neither geographical groupings, let's say. There are differences when we look at the effect of AI trademarking on different performance. So here we relate the dynamics TFP at company level with the event, which is the introduction of AI trademark. Controlling for in a typical way we used to control for selection observable, dynamic effect, anticipated effect, and so on. Here what we do find is that the results are plotted considering distinguishing the full sample of treated and untreated company with matched company. So company with similar characteristics distinguishing between those belonging to manufacturing and those belonging to the service. And what we see is that 2, 3, 4 years after the introduction of the AI trademark, there is a slight increase. No, there is an increase in TFP. However, this increase in TFP, which come out at the end of the sample period, so at the end of the autumn horizon, is strongly affected by the sample composition, because in Orbis, at least in our case, you have a lot of attrition, a lot of companies that enter late in the sample, so you have a very small number of companies for which you have a full pre-treatment and post-treatment period. For this reason, we focus on a balanced sample where we are able to track the performance of companies and twin companies without AI trademark over the sample period. And what we get the effects. So for this company, which are not, which are small number, not big, but there is a significant productivity effect after the introduction of AI trademark, controlling for traditional, we control for all other covariates introduced above. This effect, and I'm going to the end. So this effect, when this table, this graph replicate the same previous event analysis, but distinguish between high-tech and knowledge intensive service, the blue, line, and the low tech manufacturing and the least knowledge intensive service. So we adopt in our stat classification of high tech, low tech, and what we get and we see about what we see is that the uptake. So the most pronounced effect of trademarking, so if any, is for the first group, so the tech, and this is mainly driven for a selected group of knowledge intensive firms. Okay, and again, if we focus on the balance sample, so the same switcher, so those companies which are always in the same have a large number of pre-treatment and post-treatment years. So this effect is much more evident. So on average, this effect, the productivity increase is around between 50%, 20%, depending on the grouping. So, and which is not very far from what Flavio and Leah have found for the United Kingdom, which is where between 20% from the medium and 35% productive increase, where their analysis is based on sales per worker, if I remember well. Okay, so at the end, so we have tried to show that the usage of trademark could be very important to have an overview on the engagement of company in the AI domain. And this seems to not be related much to patent activities, previous patent activity of companies, neither to traditional trademark. This analysis is performed. This analysis is performed only for Italy. That could be. We are not reading AI and many other dimensions. But what we get is not so far from what has been found from OECD works. And our idea is to try to extend the analysis to United Kingdom first and to other countries in order to see whether this pattern results are confirmed or not, and also to exploit some variation in the institutional change related to the IP system that can help us with identification, because we can to work more on this. And also we are in parallel working on a regional mapping of AI related IP at European level with using crossing Eurostat regional data and so on. This is what we are doing. Thanks a lot.
Thank you very much, Francesco. So before we open the floor here for questions, let me please introduce our lead discussant to this paper. So I want to invite Johannes Dahlke to take the floor. He's Assistant Professor of Digital Innovation and Entrepreneurship at the University of Twente. The floor is yours.
Thank you so much. I will share my screen. You should see my screen right now.
Yes, we can.
Okay, perfect. Dear Leah, thank you so much for the invitation. Dear Kezban, dear Francesco, thank you so much for opening up this discussion with your nice contributions. Dear colleagues, happy to contribute to the discussion. My name is Johannes Dahlke from the University of Twente, and my discussion will mainly focus around what trademarks can and cannot measure. I think we already started this discussion at the beginning of your talk, Francesco, and for a lot of us have not been working with trademarks, I think it's interesting to think about what they can capture in terms of AI-related innovation activity and so on, and what it may mean to trademark-based AI identification strategies. I will structure the talk in a typical manner, so I will start with some of the things that I really liked about the paper. Then I will, of course, not miss the chance of taking a shot at the low-hanging fruit, some technical kind of criticism that already came up also in the discussion a bit. And then maybe at the very end, allow me to provoke you a little bit and challenge your kind of conceptualization of what trademarks mean in terms of firm performance and what they signal in terms of competitive advantage, and maybe open up a discussion on that as well. So I need to disclose a little bit of a conflict of interest before I start. This is a picture from last week. Shows me with two of the co-authors on this paper, and this is actually the second time in the last 7 days that I've heard this presentation just by a different presenter. Last week we were in Budapest at the Urbino conference, and I had the pleasure of having the paper in our special session as well. So greetings from Fulvio and Carolina, Francesco. So the good, Maybe some of you know that I do a lot of research based on web data, so digital traces left behind by firms on the internet. And so I'm very open, and of course you run in open doors when criticizing patents as a measure of innovation, very concentrated, weak coverage of digital services. They usually capture an upstream perspective in the innovation process. Yeah, we're really good at measuring research and kind of R&D activity, and we're in innovation economics. We have a blind spot for this commodification of technologies into products and services, and how they diffuse. And I really like that the paper contributes something here with a trademark perspective, because it's there where all the path dependencies in these AI transitions manifest at the micro level. And as economists, we're doing a lot of mental gymnastics with exposure-based measures, mapping patterns to industries and so on, that try to, get us to analyzing these kind of micro mechanisms. And any new measure and any new data source that is trying something there is much appreciated, as a complement, of course, to what we have been using. So these trademarks are these market-facing signals closer to product and service launches than maybe a patent. And all the rest, yeah, soft innovation, better coverage across sectors, a little bit at least, and maybe especially for technologies such as AI, a nice signal of diffusion and usage of the technology. I like particularly about the paper that you show that these adoption patterns and usage patterns are distinct from one another. Yeah, the trademarks and AI patterns, they kind of capture different kind of dimensions of AI activity. And I mean, as you could have imagined, also referring to Flavio's work at the OECD, there is a potential to integrate other types of data as well, jobs and website data. But I'm not going to nag you about that in this presentation, so I will try to focus on this trademark perspective. So it offers this nice diffusion lens, and also in the paper, you have a very ambitious kind of empirical strategy of combining it with balance sheet information. You try to link it to a more sophisticated measure of productivity, not just a simple measure of labor productivity, for example. And you have this nice analytical pipeline of this dictionary approach, then analyzing the text, matching it with the different firm level data, trying to establish causality and so on. And for an early stage project, it's very, very nice. Okay, so let me move to maybe some of the points where I stumbled across a little bit, if my slides are moving. Just a second. We should be moving to the next slide. Slide technical problems here. Give me a second. Try to reopen that. You should still be seeing my screen, I hope.
Yes, we see them.
Okay, that's good. If only I could move to the next slide, that would be amazing. Let me try again. So we try to move like this now. Okay. Okay, so some of the technical criticism. I hope you can still see my slides. I will not put them in full screen now to avoid that. So let's believe that trademarks can tell us a little bit about these AI-related innovation outcomes. Then I was stumbling a little bit about how you identify AI trademarks in the first place. I mean, what I like about it is you use this very sophisticated lexicometric dictionary approach. You have 3 different dictionaries, but in the end, you're simply, measuring keywords, and you're also saying you're classifying a trademark as a positive AI trademark if one keyword, if only there's one AI-related keyword there. And as far as I understand trademarks, they're not as technical as patents, so it's more about these slogans and kind of branding positioning. There are technical elements, of course, but it's not really legally protecting that. So there is a risk of kind of AI washing and branding that may represent some unjustified sophistication or involvement with AI technology. So especially because you have just a few hundred kind of AI trademarking firms. These small rates of false positive or false negatives, or rather false positives, can actually change the pattern quite a bit. Yeah. So what I would kind of suggest here is to, first of all, maybe try to validate a little bit what kind of trademarks are picked up by your keywords approach against a validation sample that you label. Also, would have been really nice to see the different keywords that you use. You have these 3 different lists, just for transparency reasons, kind of reporting that. And then maybe try out some stronger inference rules, right? So like maybe 2 or more keywords, consider the context window a bit. If you're familiar with my work, we use website data, which is also quite vulnerable to strategic positioning. And there we use actually a supervised machine learning model to distinguish high cost signals versus low cost signals to get rid of all the buzzwordiness, which I feel like maybe you can elaborate on that, trademarks also may suffer from. Yeah. So there I was questioning that a little bit. Then moving to the identification and causal interpretation. So you have this nice local projection diff and diff with absorbing treatment. Anticipation effects are, of course, always kind of a problem, especially when we talk about trademarks, where to me it's not quite clear what kind of signal or at what point in the adoption and application process of the technology this comes in. So does it capture really innovation, commercialization, strategy? Are we seeing like the effect of the technology, or is it already a mediated effect of the company kind of reorganizing processes and strategies and organization and so on? I think your pre-trends look kind of stable, so this anticipation effect may not be a big problem. But yeah, and then you do a nice matching, but there also it came up in the discussion already. You have different kind of options that let you rule out these unobserved shocks or shocks from unobserved observables, yeah, or unobservables. So just a few, again, low-hanging fruit criticism, maybe not yet treated with kind of a staggered adoption timing, would be a nice alternative control group. And then also not, if you keep with the matching, I'm not sure that you do. I don't think you could also match on trademark activity in general. So not compare the AI trademark firms to the overall population, but to just the population that has any kind of trademark. Maybe you do. I didn't quite catch that. And then there are other things you can do, like placebos, fake treatment years, different tests of different outcomes that are unlikely to move, and so on. In the interpretation of your evidence, I felt like I was initially confused what the balanced sample means. You explained it now in your presentation, and it makes sense to me. However, would be kind of cautious with the interpretation because we see a lot of non-statistical effects where the confidence bands kind of cross the 0 line. Yeah, so I may be a bit more cautious there. Then, if I still have a couple of minutes, Leah, or should I wrap up? I would move to the conceptual.
Please go ahead.
Okay, nice. So another kind of technical point that brings me now into this more elaborate conceptual discussion on your paper is the way that you measure productivity, right? And you have this nice approach, this rule-rich approach using production function, and you do, you apply very nice kind of technical procedure there. But then I kept thinking while reading through your presentation, there was this tension that bugged me, that trademarks are really this outward-facing, market-facing signals, yeah, of commercialization, branding, differentiation, that is really communicating to stakeholders and is trying to me, it has a very strategic intent, these kind of filings. Whereas your production function approach and also the way you interpret it is very inward-facing, yeah. So you talk about the internal efficiency and so on. And if we think about productivity, it can of course be, or maybe especially other measures of productivity, can also very, very much be influenced by the demand side, yeah, through higher markups, premium pricing, demand shifts, quality upgrading, and so on. And this is also what I would immediately assign or relate to trademark activity that to cause these kind of effects. But with your approach, focusing on these production inputs, you don't really measure that, right? So I'm wondering if there is a mismatch between really the strategic intent of trademarks and the way they measure this internal efficiency through the production functioning approach. Maybe you have some thoughts on that. So maybe in terms of conceptual tightening, I would rather move away from this efficiency argument and talk rather broadly about firm performance outcomes, and then also check against margins, markup, sales growth, and all these kind of things if you have the information, because I feel like it just inherently matches the trademarking nature of trademarks a bit better. But maybe you disagree with that. So, which brings me to this conceptual final point that I would like to make. So I think what's really nice in your paper, I said that in the beginning, is that you show that AI patent activity and trademark activity are weakly correlated and they don't overlap very much. So they likely capture different kind of mechanisms and pathways towards AI innovation. Yeah, so patents, codified invention, technical novelty, trademarks, more this commercialization, products and services offering. I was wondering if you could connect trademarks a bit better or situate it a bit better in this discourse between AI production and AI usage. What do you capture there? And who captures value? What kind of companies do that? So I felt like it was a little bit unclear still what kind of AI activity you're measuring and where you position trademarks here. It also shows in your data that both AI patents and trademarks are really rare events. Yeah, the population is very tiny and the overlap is even tinier. So maybe, yeah, so the AI, the competitive advantage from AI may be even outside patents and trademarks. Yeah, so your orthogonality that you show between the different data sources may capture different mechanisms, or it may also show that neither of these kind of data sources can really capture this competitive advantage. However, final thought now, I think maybe if we turn it around and don't look inside the company, but what the company is kind of intending with trademarks in the market, it could be a nice signal. So just connecting to some recent literature on competitive advantages from AI activity, it shows that actually a lot of the way the companies try to protect their competitive advantages do not come partly from data access, partly from model access, but also a lot from relational advantages and ecosystem and platform building, yeah, where the competitive advantage is protected through, trade secret contracts, platforms, control and dependency, partnerships, all of these kind of things, and relates to this nice relational definition by Paul Leonardi, based on Barley's work and so on, that doesn't define technology as a set of technical features, but as a set of relations that it kind of embodies. So business models moving from producing a specific kind of technology to producing a certain kind of business models that involves a very complex relational constructs of service providers, AI startups, and so on, and offering this whole package to customers and also increasing the dependency of people entering the ecosystem. Yeah. And since trademarks are this kind of outward-facing signals, they could be interpreted as this coordination device for users and partners and complementers in the ecosystem. So maybe we can use them as an early signal of companies trying to build this relational competitive advantage, where they try to protect their competitive advantage through complex relations, and of course trademarking specific kind of products and services and legitimizing them towards the ecosystem and market could be a nice signal of that. So with that, I thank you very much for giving me the chance to offer my 2 cents on the paper. Very nice work, and looking forward to hear the comments of the room.
Thank you very much, Johannes. So before we open the floor for more other questions, I don't know.
I can try to reply to some of his points. First of all, Johannes, thanks a lot for the paper, because I passed him just a slide, but so you have to revise the presentation in a week, so you learned about what we did. So I go to the point. So first, I think all your comments are very well grounded. I think the most important, from my view, the most important is about the mechanism, because to see whether AI translates into better performance through which mechanism, employment or else, or we find a relation with TFP, which somehow is a signal that trademark can be, in this area, can be used, capture some non-technological innovation. And this translates into better efficiency, because higher TFP means better. So this, I mean, so this is my first point, my first attempt to reply. The second point is about the further effect that we can find. So if TFP goes up, so we may have an increased markup or market share, or maybe we may see, I mean, while we can identify the effect of markup at firm level, we cannot do much about, I mean, with this data, with the entry rate, the business dynamics, that are all very nice topic to deepen. Okay. One other point that you suggest some point, some robustness check about the methodology. So the econometric, especially the event analysis. Basically, we are using a procedure which collapses the one you suggest when you introduce so legs for anticipation effect or delay, or so legs and legs of the treatment variable of the leg dependent variable. I did skip all this, and sorry if you didn't get from the slide. Concerning the PSM, at most we can do to isolate the effect of a rare shock that may lead the company to trademarking in AI field is basically we run a single year probability regression the year before the treatment, and so basically we do not have the time dummies because a cross-sectional regression, but basically we somehow control for with the constant with the fear for the non-servable. And so for sure we need to explore to understand better so the issue here from my view is the identification. I totally agree with you. Our idea is to exploit the UK exit from the ESCoE agreement, so as a shock that may affect somehow the propensity to apply for somehow. So this is just the idea we are working on. Of course, we can run some placebo, some counterfactual to see, for instance, whether the productivity effect, whether we identify some, random treatment companies. So we are at the beginning. I think we can try to do most of the point that you raised. So I would have to slide all I wasn't able to take all the points, but we can have a even discussion afterwards.
Great, thank you so much, Francesco. So now I'm opening the floor up for questions. Now, just a little reminder for everyone here in the room, if you have any questions, please use your microphone. For everyone joining us online today, please use either the Q&A chat or the normal chat function, and Shai and Jennifer will help us to open the microphone for you. If there are no questions yet in the room, I know we already have Flavio online who would like to take the floor.
Hello. Thank you very much. Thanks a lot for, I don't know why you cannot really see me, but great presentation. Thanks a lot. And also to Johannes for the discussion. One of the points I wanted to go back is about the mechanism, which is I think one of the points that was flagged toward the end of the discussion, and on which I would probably agree, and maybe because of the fact that trademarks are to some extent closer to the commercialization process. Maybe there is something that you may be able to do with the actual data to go beyond the productivity and look at some of the other indicators of the firms, like the sales or something related to their position in the market, that might explain possibly the mechanism through which this increase in efficiency might happen when this is more statistically significant. Perhaps maybe there is a mechanism that relates to the fact that firms that do have AI trademark reach a higher market, and perhaps this may help them increase their efficiency? I do not know, but I was just wanted to corroborate the previous, to reiterate the previous point, while congratulating you again on this very interesting presentation and looking forward to hearing the next steps of this work.
Thank you, Flavio. I totally agree with your point. Looking at other, company dimension that could be affected by this, let's say, event, if so we assume that is a shock and is exogenous, is really helpful to see the mechanism, the positioning, maybe also, yes, if the company upgrade its position in the industry, but also is able to close the gap to the frontier. So there are different, at the moment we are working on Italy. So, Italy is not the best candidate to see, if the competitiveness can increase just with trademark. But the result at the moment seem to be quite encouraging because do not differ much from what we found so far. But for sure, we need to go well into the mechanism. Otherwise, we cannot interpret it well in our results. Thanks.
Any questions in the room?
Yes. Sorry. Yes, I would have a question whether you think it could be worthwhile integrating other types of data to your analysis, such as software data. There are those existing repositories of software where you can see who develops what kind of AI-related tool that you can possibly link then to your company data if the company is available in these repositories.
Yes. This is one of the main comments that we got. This is one of the main comments that we got at the conference last week to look at the content, the semantics that we have in the patent abstract. Or with trademark, I'm not the expert on trade, but on text mining. So for trademark it's more difficult to get. I think to get more the semantic. So, but you can see whether it's talk about software. So we are trying to go towards that direction. So on this side, we have already started to see.
Luca, and then I think Johannes has his hands raised online.
Thank you, Francesco. So I typically have an easier time understanding the AI effects on TFP for the users than for the producers, right, of AI, which is what you capture with your patent variable, right? So this is, I think, a very small suggestion. So perhaps you can integrate in your presentation some examples that make us, that introduce us to why AI patents improve the productivity of the AI inventor in a way. Because of course, yes, if it's an AI which is labor substituting, then down the line, I'm expecting that the company itself, substitutes labor with capital and then increases in productivity. But other types of AI may really not be very useful for me, as opposed to be commercializable and be useful to somebody else. And in that respect, second small suggestion, perhaps you do show that most of your effect is driven by high-tech firms. Those may very well be firms in the, let's say, ICT producing sectors that are actually patented their AI for somebody else and not for their own use. And so your mechanism is blurrier, I find, for those firms, right? So your interpretation. So does any of this hold without the high-tech firms, where it seems that the connection between AI and AI production and use for productivity enhancing things in the company seems to be, tighter?
Okay, thank you, Luca. This is very, the pivotal point in the literature. Indeed, intentionally, I never mention whether we are measuring AI developers, users, or producers, because honestly, I don't know. Because we need to get into the semantics to know. So whether they use software, if they introduce product or not, Leah and Flavio talk about the adopters crossing information from different sources. People working on patents used to associate patents to developing of the technology. But I think my personal view that with AI, I mean, I'm closer to your approach. For me, with AI, if you introduce an AI patents, let's say, or trademark, it's likely that we are using it. For instance, we have done a research with in Italy for the bank sector with this guy, my master student, and we found that Unicredit Bank, I can say, apply for an AI patent. AI patents. Unicredit is going to sell its patents. No, I think it apply AI patents in order to maybe credit scoring, in order to manage the portfolio. So intentionally, I didn't mention this distinction because we are still conceptually working on this. So I totally agree that the way you suggest is a way to, so looking at the semantic, the content is probably the best way to see at the end if with this IP, we are measuring not only developing technology, non-technological innovation, but also the usage, because it's key, the usage. 5% of firms you develops, potentially 100% can adopt it. So, I think this is very useful.
Thank you. Johannes?
Yeah, thank you. And I also have to say that you do a very nice job in kind of creating the transparency about the different descriptives you show, right? In terms of who trademarks and patents and so on. So that's also much appreciated. I was wondering just one descriptive, because you showed the geography in Italy, and then it was peculiar that in Veneto and Tuscany, the trademarking activity was above average. So obviously famously touristy regions. Do you have any hunch on why that may be there in terms of the ecosystem in these kind of regions?
Sorry, John, I didn't get well your question. Possibly.
I think you showed in the geographical distribution of AI trademarks that they were that they concentrate in the regions of Veneto and Tuscany, right? So those are famously touristy regions. I was wondering if you have any interpretation of why that may be.
I mean, the figure is so small that you could have 10 more firms that are divided by 100 province. Maybe the color may change rapidly. So I don't know. I honestly, I don't feel to draw conclusion on this. Sorry, but the number is so small.
Fair enough, yeah.
I mean, it gives an overview about that. I mean, when we look at manufacturing, you see AI outcomes on, I mean, in areas specialized manufacturing, patents, Lombardy, Torino area, and so on. Here we have a different belt in Italy that could be maybe from a policy perspective would be nice to have to have some region starting competing in an area where we guess or we're not strong, let's say.
Thank you. Are there any other questions in the room or online? If not, I may abuse my role just very quickly for a couple of seconds. And I wanted to ask you, because my understanding is that the AI that you're capturing here is probably more of predictive nature. You may also have generative AI in there, and this is a bit, no?
We have not done this. No, just based on dictionary. So
yes.
No.
Okay.
Not in the agenda yet to look at the
so this is a bit of a self-serving question as well, because we are actually right now also moving away a bit from the keyword and dictionary approach. And right now we have Flavio and Yelma and myself are working on a project on generative AI, in particular, using generative AI to identify generative AI related patterns. So it's a
I don't think what we are doing with Ludovic and other colleagues. Sorry, what we are doing is more following the innovation literature that we do the semantic. For instance, in a similar sample, we construct some measure novelty, basically, because would be. It's a way to go towards the direction to have only, even in terms of outcomes, AI, so a binary indicator. So we are constructing some continuous variable where basically we are trying to map this company in the technology space, comparing the content of the patents compared to the past, following the literature on, Kelly and so on. We are already, for instance, we are measuring, we are constructing continuous measure of novelty based on AI, digital and green, say, with Nicola, which is PhD student working on this. So we are moving towards the direction but you can do from a view mainly with patents. On trademark, here, you have a much less smaller number of characters, so different, so images,
Yes. So we are also just applying this to patents right now, not to trademarks. Yes. Once we have a draft ready, then we'll share it.
Thanks.
Okay, so I think now we are coming to an end. We are close to 3 o'clock, so I would like to seize this opportunity to, of course, thank everyone here in the room. Thank our speakers online. Thank you very much, Johannes, for joining us. Thank you, Kezban, for your welcoming remarks. Please let me also thank you, Francesco, for an excellent presentation. So
thanks for.
And let me just now. Yes, thank you. And just remind you all of our next PI seminar, which will take place on the 19th of March, and which will be done by Marina Rybalka from Statistics Norway. And the presentation will be From Startup to Scale, a study of Norwegian startups and scale-ups. Thank you all.